join. Cool. So basically, we're just going to continue where we left off last night. So again, recording will be shared later when it's uploaded, and then I will share the presentation as well, so that we basically then have a presentation of last week and yesterday and today's sessions that we went through. Okay, so again, what we're going to do tonight is just going through random selected questions. So some of it is a bit blurry because it's from previous printed exam papers, and there are that are better that we got from online papers and some of the previous assignments. And then again, please feel free to share any questions that you guys might have. I will add that to sessions on a presentation for next week. So I will just bolt on this presentation and add it to the sessions we will have next week. Okay, so in this one, we need to, this is the linear programming chapter where this comes from, but they basically giving us, instead of a linear program graphical display, they are giving us a word sum, and out of this we need to get to these formulas. Okay, so let's read through it, and then we can by step and also through that process first start eliminating some of the options before we get to the final. So Tabiso and Manette or run a company that manufactures two types of gifts, type 1 and type 2. To manufacture a type 1 gift requires 2 minutes on machine A and 1 minute on machine B. A type 2 gift requires 1 minute on machine A and 3 minutes on machine B. There are 3 hours available on machine A and 5 hours available on machine B. Okay, so the first thing need to note that is minutes, and this is hours. So already there is 2 different in this one, 2 different measurements. So very careful when we look at the answers. One is in minutes, the other one is in hours. When I say let X be the number of type 1, so X is type 1 and Y be type 2, so Y is not type. I'll do that right now. So that is type 2. So let's just start reading again. Type 1 gift requires 2 minutes on machine A and 1 minute on machine B. A type 2 gift requires 1 minute on machine A and 3 minutes on machine B. There are 3 hours available on machine A Okay, so let's go. Machine A said there are 3 hours available on machine A, so you have a maximum of 3 hours, but 3 hours is how many minutes? 180 minutes. Then on machine B, they said, let's quickly, and 5 hours available on machine B. So 5 hours available is maximum of 300 minutes. So smaller or equal to 180, smaller or equal to 300. So I'm looking at these and I'll say, okay, there's 180, there's 300. Okay, so everything is still looking fine. So let's again go back and say to manufacture type 1 gift requires 2 minutes on machine A. Type 1, 2 minutes on machine A, and 1 minute on machine B. And then let's check what is Y. The type 2 gift is Y, requires 1 minute on machine A. That's 1Y, and 3 minutes on machine B. Okay, so let's now look at it. 2x plus y is less than 180, so that's correct. X plus 3y is less than that. 2x plus y less than 300, so that is, those two are wrong. X plus 2y, so that again is wrong. X plus 3y smaller or equal to, so that was right, but that one was wrong. X plus 2y, okay, so that one is wrong. 3x plus y, so that one is also wrong. So we basically could then get to option 1 with 2x plus y smaller or equal to 180 and 1x. So again, it's a bit bad review of the old exam paper. So it was a paper-based exam. So the view is a bit bit sketchy and not that great. So the x plus 3y is smaller or equal to 300. Okay, so option 1 would have been the correct one. So this one is around the work around linear equations, where they basically give us the linear equation information via a word sum. We will do a few where I think today or next week where we will get graphs as well. So that is also in the bigger pack. So this was also an interesting one. So what, again, I'm gonna just rewrite this because in one of your chapters there was work on notations, and then part of it was summations. So here they're giving us a formula, k times k plus 1 divided by 2, and they say we need to work out the summation of that from K2 to K9. Okay, so that is what this means, is that we're gonna work it out for K2. Then we're going to say that plus K3, K4, K5 up until K9. So when we put in 2, it is 2 times 3, which is 6, divided by 2. So I'm just going to write it down so that you can see what we will be doing. So that is for the value of 2, but we need to go up until 9. Not just 2 and 9, from 2 till 9. So we will need to then say, okay, we need to replace it, the K with 3. Then replace with 4. Then with 5. And that already is also, be very careful that you don't, because in this one again, it's very easy to make mistakes. Then 6. Then we need to add 7. I'm going to fill in now 8 and 9. So I'm just quickly working backwards so that we just capture all of them. Okay, so that is what we needed to do when you see this formula and what we need to work out. So we need to work out the sum from 2 up until 9. So let's make it a bit simpler. 2 goes into 2 once, 2 goes into there, 2 plus 1. So that is going to be 3, that answer. 3 times 4 is 12. 12 divided by 2 is 6. Is it going to be a pattern here? Probably not. 4 times, what is that? 5 is 20. 20 divided by 2 is 10. I hope I'm doing it right. 5 times 6 is 50. 50 divided by 2 is 15. 6 times 7 is 42. 42 divided by 2 is 21. 7 times 8 is 56. And 56 divided by 2 is 28. 8 times 9 is 72. 72 divided by 2 is 36. 9 times 10 is 90. 90 divided by 2 is 45. And then we need to add all of them together. Again, this is not a quick process, which is unfortunate because it's not a difficult one, but it is time consuming. And that is normally the problem with these ones, is that it does take a lot of time, and very easy to make a mistake. And the answer is 164. So you can also see how close these numbers are. So it's 164, 165, 166, 167. So also very difficult nearly to look at it and say which one it's going to be. It's not one that is really big or really small that one can say, no, that's not going to happen. So very difficult also nearly to eliminate any of these options. Okay, so this one is quite a long process, and unfortunate in your fortunate or unfortunate, and this will be the same marks. So this one definitely took much longer to complete, but probably a bit easier, but it will take time, and that's nearly the unfortunate. There wasn't really a shortcut in that process. Okay, then another component that you guys need to do is to be able to solve for equations. So some of your calculators actually can do this. So if you look at the Sharp and the Casio, I think you can actually use this and put this into those functions. What you can also do is to test yourself or to test what your answer is. You can always use, and I normally use one of the, so what is it? Simultaneous, spell it correct now. Equations. And when I just put in okay, so you can always go and test a simultaneous equation. So there's, and I will again put this into, it's not that, I don't think you guys are allowed to use this in the exam, but you are always allowed to test it while you are practicing if you're actually doing it correctly or not. Okay, so we are, and what is also nice about the online functionalities is that, let's put that in so that I can show you. So x plus 2y equal to 10 and 2x plus y is equal to 14. Okay, so let's check that. So what they also do is give you a lot of the, if you need to now see how to work it out. So they show you also how to work it out. So sometimes they show you by substitution. You can then choose substitution or elimination. So you can nearly decide which one you want to look at. Okay, so this is quite a nice one to use. So there is links, but let me show you just how we would do it as well without having the online facility available. So when I look at these two equations, I've got x plus 2y is equal to 10, 2x plus y is equal to 14. So I need to, if I want to substitute, I need to make one of them say x is the subject of a formula, and then make the other one that it is x is equal to. So this is for one method of doing it. So x is equal to 10 minus 2y. And then in the second function, I will substitute my x with this, 10 minus 2y. Then we can work out what my y is, so that I can then use that y back into the original formula. So 2 times x, which is 10 minus 2y, plus y is equal to 14. So if I work that out, like we did yesterday. 2 times 10 is 20. 2 times 2y is minus 4y. Plus y is equal to 14. So on the left-hand side, I've got minus 3y. If I take that 20 over, it becomes negative 20. So negative 20 plus 14 is equal to negative 6. Y is equal to 2. So if I look at these options, that will automatically then default to option 4. But let's just put y equal to 2 back in here. So we've got x plus 2y is equal to 10. If we substitute y with 2, we get that x plus 4 is equal to 10. So when the 4 goes to that side, it becomes negative. So then our answer will be x equal to 6, okay, which would have been also given us that. So that's one way of doing it, bit longer than usual, but that is if we substituted it. Another way to do it is to not substitute, but to say, how can I make it that when I add the two formulas, or if I subtract the two formulas, that I can eliminate something in it? So I could have said, okay, there's a x, there's a 2x. So let's multiply the first one with 2. So then I get 2x plus 4y is equal to 20. And then I could have said, okay, I've done that. So this is formula 3. So if I just then say my formula 3 minus my formula 2, formula 3 minus formula 2, 2x minus 2x is 0. 4y minus y is 3y. 20 minus 14 is 6. So by that way, y is equal to 2. And if I put y is equal to 2 in any one of those, I will get x is equal to 6, which will give you, again, the same answer as the previous one. Yes, there is a hand. Please ask a question.
Irene, okay, I'm a bit confused. Maybe this is not how I do it. So the method that I use basically is whereby say what you did on the left to also do on the right. So sometimes I
Okay.
get it wrong, sometimes I get it right. So I'm not sure on this particular method. I'm still trying to navigate around it.
Okay, so when you do that, do you also then have two variables or only one variable?
Okay, so it's normally when I have one variable on,
Yes.
like, yes, not normally with two. So I'm
S-
not sure if that method could work on this particular equation or not.
See, so what you could have done, see, with one variable, it works very nicely, and continue with that for one variable, because it it really works with one variable. It's very difficult with two variables, because the difficulty is normally that the one variable won't disappear. So whatever you nearly do, it will not disappear. here in, so that's why you nearly need to or substitute it or change it a bit that you can work with it, because you what you are allowed to do, and this would have been nice if, let's say, it was something like, if there was, let's say, no, that's not going to work. So let's just first take that on its own. So whatever you're going to do on the left hand side, you must do on the right hand side as well. So if you want to say with this one, let's get rid of the x by saying minus x, which is fine. But because you need to do it on the other side, you're just moving your problem from a one side to the other side. Um, so that's normally the difficulty when we're solving two equations, is that you can't just do the same on both sides, because it will not really help you in that problem. So you nearly need to be able to say, I need to get rid of something. And you could have said in this instance, but again, that's going to make it a bit more difficult. Um, so if you want to say, and if it was something different, divide by a x so that the x can disappear, but then you're making it a bit more difficult. So the easiest one, nearly, when you have the two, specifically when it's two variables and you need to solve it, I normally like to use this method, because that is how we also going to look sometimes at when we look at graphs and things like that. We are going to make nearly something the subject. So normally we will make it y is equal to the mx plus c1 that we also did yesterday, so that we can graph it. But normally it's much easier to change this, that it is in the format of something is equal to the y plus the constant. So we could also have said, instead of changing this one, we could have used that second one and said, okay, I know all my lines is normally y is equal to. So I could have changed that one to say that is equal to y is 14 minus 2x. So what you also can do, and that's maybe another point, is if the second one was something like y is equal to, now let's just, I'm going to divide that everything by 2, because then we can get the y is equal to. So if we divided everything by 2, we could have said, okay, so that is equal to minus 5 over x over 2. So then again, you're allowed to say, this is y, that is y, the two are similar. So 5 minus x over 2 will be equal to 14 minus 2x. So that again is something that you are allowed to do. But you nearly need to change the formulas that you can say the one is equal to the other one. So this, you are more than welcome to do it like this as well, because then you have transformed the two, that you can say, well, the one is y is equal to, the other one is y is equal to. So I can actually say 5 minus x over 2 is the same as 14 minus 2x. And again, it doesn't need to be y is equal to, it could have been x is equal to, like this top one. But it's nearly always important that it is one of the variables is equal to the other variable plus the constant, and not the two combined on the one side, because that makes it difficult. So if you can get all the variables on the left-hand side and all the other variables on the right-hand side. So if it is all the x's on the left, all the y's on the right, then at least you can also start eliminating, which you're also allowed to do. But it's very difficult when it is in this regional format to then say I'm doing something on the left and I'm doing something on the right. But when it is in this format, then it is much simpler to do that. I hope that that helps a bit. So I'm gonna see if I don't have a few more of these that we can bring it into our other sessions as well, because again, this is, I know that they're gonna ask this for you guys. So it is important that we make sure you can do it. So I will definitely bring a few more of these into play. Okay, then so, and that is also nearly looking at linear equations. So then we move a bit on from linear equations to quadratic equations. And this is also one of those that, let's see what they ask. There's two questions based on this. But let's see. So they tell us here is a parabola or quadratic equation with that is A is a turning point, D and C goes through your x-axis, that goes through your y-axis. They give us the information about the graph, and then they ask us a few things. So first they ask us determine the coordinates of A. Okay, so what I normally first do is I check this out. I see, okay, here we have the B coordinate, so that's where it's the y cutoff. So we know x is 0 and y is minus 3. So we know that point is minus 3. So if that point is minus 3, this point must be smaller than minus 3. So I'm going to look at these and I'm going to say, okay, yes, minus 4 is somewhere here, so it might be minus 5, also somewhere here, so it might be minus 3. No, because that point is minus 3, so definitely not option 3. And then I'm looking at, okay, I also know this is not scale, but it feels like minus 12 will be somewhere here, but let's just assume it can also be. But at least now we've got one eliminated by just evaluating the graph. Then I'm looking at and I'm saying, okay, okay, so x is definitely positive. So let's just look at the x's. Yes, positive, positive, positive. Okay, so by just examining the graph, we said, okay, there's one option that's not the option. Okay, now we can nearly go into a bit of detail. So we know that point A is your turning point, so we can work out the x of a turning point, and there's a formula for that. It's the minus b over 2a. So we've got the original function, so we know that is a, b, and c. So minus b is minus minus 2 over 2a. A is 1. So we've got plus 2 over 2, which is a x value of 1. Okay, so there we've got the x value of 1, 4, 5. So we know that is then also not going to be, but let's just work out or see how we work out the 1, or option 1. So how do we get the minus 4? Well, we know that x is 1, so we can substitute it back into the original. So if x is 1, what is the value of y? So that is 1 to the power of 2 is 1, minus 2 times 1 is minus 2, minus 3, so we get that the y value is minus 4. Okay, so that is how we got to option 1. Okay, so and you don't need to nearly evaluate and look at it. You can go into this automatically, but there might be sometimes that you can eliminate more options. So it might be that there was an x that's negative or something like that. So sometimes there is maybe a different one that you can also eliminate. But then we use this formula of the y, the turning point for x, and then I also have written that down on the formula page, which I will share again over in the week. I just want to scan it, that it's not a picture, but it's a better quality, and then I will share the PDF with you guys. Yes, there is a question.
Okay, say, I've got a question here. I didn't understand from x is equals to minus b over 2a. Where did you
Yes.
get that from? I just
Okay.
want to understand it. I'm a bit lost.
Okay, cool. So this formula is the formula for the x value in the turning point. So let me quickly check. I have the page number in the study guide as is that now spelled correctly. I just quickly want to give you the page number. It's always nice to have that information. So let me just quickly check for you. Where that turning point formula is in quickly. I hope it is in there. So let's quickly turning point, page 159 in your study guide. So from page 159, they also sometimes name it the vertex, which is really not, I want to say not proper English, because again, English is not my my first language. So they sometimes call it the vertex as well. But basically it's the turning point. So that is page 159 in your study guide. They talk about the turning point of a quadratic function, and then they go into the details of that turning point, and then if you work out the turning point, how to get to the intercepts and all those kinds of things. And then they also talk, and I think the next one is linking to this. So they're talking about the discriminant and how to get to the x-intercepts and those kind of things. We will do that in question 17 of this, but it's all based on that component 2.3 in your study guides around the quadratic function. Okay, so let's quickly go into the next one. So we look at the same, and let's just make that a bit bigger. So we're still looking at that same equation or same formula, and when they ask us, but what are these 2 points? Okay, so the first thing I again can see out of it, so we still have that reference where x was 1. Okay, so let's quickly check. So that point was 1 and minus 4. So all of these points is lying on the y is equal to 0 line. So all of those points, we know that the y will be 0, but we will need to work out what is the x point. So, okay, we're happy, all of them, the y's are 0, the y's are 0, the c, the y need to be negative, or the x need to be negative, so that's unfortunately all correct. The d, all the x's need to be positive, so unfortunately, again, that's correct, we can't eliminate, but I can at least see that point D, because this is 1, that point D can also not be 1. So at least I can say, hang on, my point A was 1 and minus 4. So point D, there's no ways that can also be 1 and 0, because then 1 and 0 is lying there. So there's no ways that can be 1 and 0. So I can, by just looking at the graph again, was able to eliminate one of the options. So yeah, that could be minus 1. It could be minus 2. So don't know. That can be 4. Can be 3. Probably not 2, but yeah, it can. So it's not that we can eliminate any of the others by just looking at the graph. So now there's 2 ways to solve the x point. So you can use, again, on page 164 in your study guides, it will also be, the formula will be on, will be on your formula sheet that I will share with you guys as well. But the formula is x is equal to minus b, and again, it's not something that I always remember, because I always have a book with me that I can look it up. So it's not that you're gonna ever nearly need to know this off by heart, but minus b plus minus b to the power of 2 minus ac divided by 2a. So that is, you can always use this to get to those 2 points, and it will work out. Another method is to say, but we factorize that. So I'm going to show you both. I'm more comfortable in factorization because I've done that so many times, but I will show you both so that you can see, and you can use both. So when I look at this, I would have said, okay, let's factorize it. So if I factorize x to the power of 2 minus 2x minus 3, we will have x and x, so that will cover that one. We know it's minus 3, so the only way to get to minus 3 is by the 3 and the 1. The negative, it's negative 2, so the minus will go with a bigger one. So here I now have x minus 3 must equal to 0, or x plus 1 must equal to 0. So x minus 3 is equal to 0 makes it that x is equal to 3. That will be that point D. And x plus 1 equal to 0 makes it that x, and I will take that plus 1 to the right-hand side, so x is equal to minus 1. So point C will be minus 1. So then if I look at this, minus 1 and 0, that's correct. But that must be 4 and 0, so that's incorrect. Minus 1 and 0 is correct. 3 and 0 is correct. So the option would have been C. So that is if I factorize it. So let's say we did not know how to factorize it. And what we will do is we will use this formula that is in page 164 of your study guide. So let's do that. So we need to say x is equal to minus b. Remember that is b, so minus b is that, plus minus, so minus 2 to the power of 2, so we will work that out now. Minus 4, a is 1, c is minus 3. And then we're going to divide that by 2 times a, so 2 times a is, oh, that looks terrible, is 2 times 1. Okay, so let's then simplify a bit. Minus times a minus is a positive, so we've got plus 2. Then we have plus or minus, and let's see in the brackets. Minus 2 times minus 2 is positive 4. Minus 4 times minus 3 is positive 12. Okay, so underneath, and then 2 times 1 is 2. So positive 2 plus minus 4 plus 12 is 16. Square root of 16 is 4, and all of that divided by 2. So basically we've got 2 plus 4 is 6. 6 divided by 2 will give us the 3. Or we've got 2 minus 4, which is minus 2 over 2. So, and minus 2 over 2 is minus 1. So there you could see exactly the same. We've got it, the x as minus 1, the x as 3. So again, didn't matter if we used factorization or this formula, we will get x is 3 or x is minus 1. Okay, so again, just showing both so that you can again decide which one is easiest. I like factorization because I'm comfortable with that, but this one is actually sometimes easier because you substitute from the formula, and then it's not something that you now need to see suddenly, as in factorization, how I will get to the factors. Here, you can get to the answer without knowing how you need to factorize it. So again, nearly depending on which one is the easiest for you, there are two methods to solve it. And I think that's always nice with this one is you can use any one of the two methods and you will get the same answer. So again, I will tonight share the presentation and the recording on our WhatsApp group. So if you want to go and practice this, there is now two nice slides for you to see which one you feel the most comfortable in using. Okay, then this was in one of the previous, when it was still paper-based papers, and this was really a terrible question nearly. So they said South African law stipulates that if a loaf of bread is not labeled, it must weigh 800 grams, with a leeway of 5% under and 10% over. So the person wants to know whether private bakeries adhere to the standard, and when they say here's the records of the last month, or not even the last month, it is the last 10 loaves of bread in each week. So Mondays, the last 10 loaves, Tuesdays. So they then say to us, determine the mean mass of loaves for Thursdays. So basically, what is the average of the loaves for Thursdays? So what we can do is you basically need to say the sum of the weight of the loaves divided by how many, and they're supposed to be 10, but let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divided by n, which is 10. Now, again, two ways of doing this. So you can go and say, I'm adding all of those up. So you can use a calculator to add all of that up. So, or you can use Excel to do that, but let's use a calculator for this one. So basically, I'll show you both again. It's 807.4 plus 798.7. So let's show that on Excel. I just quickly want to open up a spreadsheet Did we use anything last night? No, I don't. I will just check. But okay, so let's put this in. Let's just make it bigger. So we now only going to look at Thursday. So there was 807.4. So on your calculators, one can do it as well. So 807.4 plus 798.7 plus 809.3 plus 791.1 plus 820.4 plus 799.8 plus 790.7 plus 801.8 plus 789.2 plus 826.0. Okay, so then you would have been able to say, okay, the sum of that, so that is how we would have done it on the calculator. The sum of that divided by 10 would have given us the average, or in Excel, there is also the function of mean, which is just average. So we could have just set the average of all of those things, and it's supposed to give us the same answer. So 803.44. Okay, so we could do it with the calculator, adding all of it divided by n, or we have a built-in function within Excel that also works out the average. So it does give us the same answer. Okay, but so this one is a bit more straightforward. It doesn't matter if we use calculator or Excel, we can get to this answer. Okay, but there is, on this exam, there was a 14 and a question 15 also based on it. So, wait, so that was question 13. So now we need to look at question 14. So determine the median of the masses of loaves for Tuesday. Okay, so now we needed to look at the Tuesday one, and we need to look for the median. Okay, so again, this is very time consuming because median is the number or the value in the middle of that numbers. But in the middle, as in when data is ordered from small to large. So it needs to be ordered from small to large. And then that data point in the middle, that is the median. So automatically you can see, okay, so we've got 10, but look at there, it goes up, down. So we actually need to organize that from small to large before we can get to the median. So we need to look at the Tuesday one. So that again is sometimes why it's easier to do it in Excel, because now Excel does have that built-in function to order the data. And it also does have a built-in function to work out the median. So let's show you both quickly. Again, I will share the spreadsheet, because else you need it now to write this down on a piece of paper, which is also fine, but just make sure then that you order it on that piece of paper, because that is the most important part of this, is that you are able to order it by ranking it from smallest to largest. There's not another way to say, to look at it without using the order. Yes, there is a hand. So while I'm typing, you can ask. Okay, I'm not picking up sound. Okay, so while you can also type a message if a sound is not working. So what I'm quickly going to do, show you guys. So there is a built-in function median. So if I select those data for the Tuesday, I can work out that the median is 796.1. So there we have 796.1. But without using that built-in, I could have also set in Excel, okay, the main reason why I want to use it is because it needs to order it for me. So there is that sort and filter. So we can say order it from smallest to largest. So that is still there. So let me just quickly undo that. I just want to have a gap between, so that that is also not ordered. Okay, so now we've ordered it. So now you can see it goes bigger, 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 bigger. So definitely from smallest to largest. We wanted the one in the middle. So there's 1, 2, 3, 4, 5 at the bottom. 1, 2, 3, 4, 5 at the top. So basically the number that's lying between those two. So another way to work that out is to say, well, it's the one number plus the other number divided by 2. So that's another way that we can look at it. And you can see, again, we get to the same answer. So the median, we can use that to say, well, it's the middle two numbers. So that's number 5 plus number 6 divided by 2 gives us the median. Or we could have used the built-in function within Excel that also looks at the data, ordered, not ordered. It, in its mind, Excel does it itself. And then you can see it is exactly the same answer. Okay, so I will definitely share this spreadsheet with you so that you can work out questions 13 to 15 in this as well. But again, if you don't like Excel or don't have access to Excel, the same method used here, we could have done on a piece of paper and said, okay, what's the smallest number? 7879787. So the smallest number is 780.4. What's the next smallest number? Okay, so it is 787.4. So we could have done it that way as well to get to the median. So you don't need to have Excel, because again, you could have looked at that data, and then when you get to your 5th and 6th points, you can just add the 2 points and divide by 2 and get the median as well. So again, not always needed to have Excel. There is other ways of working these two out without Excel. Okay, there's also, and again, you guys can let me know which calculators you're using. So on the chat, you can just put in your calculators, because all three financial, the cashier, the shop, and the HP, have the functionality where you can put in data, and it can, well, it doesn't work out the median, to be honest, but it can work out the average and standard deviations and those kind of things. My HP can definitely not work out the median, so I don't know if the shops and the cashiers can do it, but I can look around for guides that I might be able to share with you guys that can assist if you have a financial calculator. So if you want to put in on the chat in here what calculators you're using, I can look for some manuals to see if I can't share a manual or two with you guys, so that you might be able to use your financial calculator for it. Okay, and then they went on to say you need to determine the standard deviation. But for standard deviation, what they told us is determine the standard deviation of the masses of loaves for Sunday, given that the mean mass for Sunday is 799.28. Okay, so this is now, again, a lot of work. So let me just show. So this is a bit unfair if you guys need to do something like this in the exam. So let's move that over there so that we can have a space here for the Sunday one, so that I just want to go in the detail if we did not now have something like Excel. So that's 799,806, 799.4, 801, 796.7, 802.2, 807.3, 809.8, 791.2, 790.2. And they told us, and let's just put the mean in there, was 799.28. Okay, so let's first work out the mean as well, if that is correct. It should be. So, but just so that we know it is. Okay, so it's exactly the same as what they've given us. So if we were now going to do this on paper, the formula that we would have used is gonna say that first x point minus the mean. So remember, out of the formula for the standard deviation, so what we then need to do is to say that to the power of 2, that we need to sum for all of them. Okay, so you need now to work that out 10 times, because it's 10 different points. I just want to check that so it is a bit unfair to ask this in an exam, so hopefully they don't. Then we need to say the sum of all of those divided by, and it will say it's a sample. It will say somewhere we're working with samples, or is it population? Oh, okay. Yeah. So that's also, so it will be interesting to see which one, because we could have now used both. So let's first do that. And then we need to say that square root. So 8,1, I say it's not there. So that tells me it is 10 minus 1, because it is sample, when it's 8,61. Okay, so there is the answer that we're looking for. So it is a lot. If you now needed to do this on paper, because you needed to say, and let me quickly write down the formula, you would have said that x point minus the mean, you would have made that to the power of 2. Then you would have done that for all 10 of them. You needed to add them together, and then you will say n minus 1. So that is for the variance. And then to get to the standard deviation, we will need to square root that. Okay, so this is a lot of work if it is this big a sample for you to do on paper. So if it is in Excel, that is the long way how we got to it. So that would have been, and let's do it this way, that would have been the variance, our standard deviation. But let's also show you guys, so there is a variance for the sample in Excel built in, and there is a variance, a standard deviation for the sample also built into Excel that will give you exactly the same. Okay, so what I did to the second column was basically that was the xi minus x to the power of 2. That is what quickly was the xi value minus the mean to the power of 2. So that was basically doing this part of the equation. So that was that part. Then I needed to do it for all 10 of them. So what I could have built in here is to say, instead of doing now that sum, I could have rather said that is, let's do it that way, that you can see it rather in that format. So let's see, I think there's an orange one as well. So then this is the orange component. So that is the sum of all of them. So that is what I did here, the sum of all of them. And then that variance is that sum of all of them divided by n minus, sorry, so 10 minus 1. And you will see, so that variance, and let's give it green, is now there where we set that whole thing divided by n minus 1. Okay, so there is that variance we've now calculated there. And then if we take it a step further to say the variance square root, that is our standard deviation. So that is the standard deviation that we have there. Okay, so that is nearly how to break it up. So that's all the x minus the mean component, all of them for x1, x2 up until x10. That is the sum of all of them. So that you have a sum of all of them, then the variance is that component that we did, and that is the standard deviation. So I will share the spreadsheet with you guys as well as the presentation, that you can familiarize yourself with it as well. So you are allowed to use Excel, you're allowed to use financial calculators, you're allowed to use any, you can scribble, you can write this down, you can, so you are allowed to work on paper, work it out, you are allowed to use Excel, you are allowed to use financial calculators. So again, nearly you've got some time to practice a bit if you want to use Excel and get it right. We will, again, up until when you write exam, I'm going to share some of these questions, and we can then also look at all the ways to work this out. Okay, so I will share all of the things on our WhatsApp group with you as well. Okay, then there was this question again, and remember last night we also had a question on combinations and permutations. So again, we're going into combinations and permutations, and what they did in this paper was nearly asking you, and it might be both ways. So let's first look, and again, I will read it out. It's one that was in a previous exam paper. So an investor has decided to purchase shares in the stock of three companies. One engaged in aerospace, one involved in energy, one involved in electronics. After some research, the account executive of a brokerage firm recommends that investor considers stock from 5 aerospace companies, 3 energy companies, and 4 electronic companies. In how many ways can the investor select the group of 3 companies from the account executives list? Okay, so this is a interesting one, because you can have 3 companies, and after research the account recommend the investor stock from 5, 3, and 4. So one must be engaged in aerospace, and there is 5 aerospace companies. One must be involved in energy, and there's 3. One must be involved in electronics, and there's 4. Okay, so how I would have done this is to say you've got 3 spots. That's with 3 companies. One must be involved in aerospace, and out of that, you've got 5 possibilities. One must be involved in energy. One must be involved in electronics. So I would have said for that first one, there's 5 possibilities. For that second one, there's 3 possibilities. For that third one, there's 4 possibilities. So 5 times 3 times 4 will give me my answer. So it's not that, which gives us, just check if that gives us 60. So it's not that you have 5, 8, 12 companies in total, and for the first one, it can be any one of them. For the second one, any. So you know there's only 5. So you can pick 1 to 5 from them, and then it's it. Then for your second pick, you have 1 out of 3. So it's not that for the first one, you have all 12 available. Then for the second one, because you picked 1, you have 11 available. And then for the third one, because you picked, now you only have 10 available. So it's not like that. They said one must be engaged in aerosmith. Aerosmith. Aerospace. There's only, gives away my age as well. There's only 5 in aerospace. Then you must pick 1 from energy. There's only 3 in energy, and 1 of electronics, and there's only 4 in electronics. Okay, so that's how we would have gotten to, there's 60 ways that investor can select the 3 companies. Okay, so that's on this question. The next question, they now change it a bit. So they say, suppose the investor decides to purchase shares in stock of 2 aerospace companies, 2 energy development companies, and 2 electronic companies. In how many ways can the investor select the group of 6 companies for investment from a recommended list of 5 aerospace companies? Again, 3 energy and 4 electronic. Okay, so now what comes into play is you basically have, for that first option where you have 2 aerospace, so there's 5 of them. So if you pick 1, it was 5 possibilities. If you then need to pick the other, there is 4 left. So that is for the aerospace. So now you go to the energy. In the energy, how many was there? There was 3. So if your first choice is one of the 3, you picked that one, there's only 2 left for your second choice. The same now with the last one, which is electronics. So, and there is 4. So the first round, you're picking out of the 4. The second round, 1 is less. So you pick out of 3. So this now will be your set of options that is available. And interesting, because I don't see any of these. So let's just make 100% sure, because that is 20 times 6 times 12. Let's just make 100% sure. Of 2 aerospace, 2 energy, 2 electronics. How many ways can the investor select the group of 6 companies for investment from a recommended list of 5, 3, and 4? Okay, so that is what we're supposed to do, but let's see, is it combination or permutation. So permutation is, and we looked at it last night, so let me just quickly get the, not the formula, but the definition of that. Where was that? So let me quickly check. Permutation. If anybody sees it somewhere in the study guide, you guys can let me know. Else I am going to Google what it means. Okay, so let's quickly just do this permutation. Okay, so I just want permutation or arrangement of objects where the order is important. Okay, so we don't mind about the order, so this is combinations. So for the first one, 5 combination 2. For the second one, 3 combination 2. Okay, so all is combination 2 because we basically pull 2 of each. So we can again use your calculator with a combination sign, but you can also use Excel. So it's actually 10. I will just want to check that again. 3 combination, 3 combination 2. So I just want to make 100% sure that we now working with the right numbers. So then it is 4 combination 3. No, that is not right. 4 combination 2. And so I get 6. 10 times 3 is 50 times 6 is 180. So let's just quickly make sure. 5 combination 2. Okay, because the formula, so I now used. So let's quickly show you guys the formula. I will copy that in as well. So I used the permutation rule and not the combination rule. So that's why that was wrong. So that is important. So I'm going to add this for you guys so that we have it in here. Okay, so that when you need to look at it, I still don't know where it is in the study guide, so I will look at the study guide later tonight again and see where that was, because I know it's somewhere in the study guide and I really don't see it now in the summary of a study guide. So I assume it is part of that revision of prior knowledge. I think it's somewhere in there, but I can't now see actually where it is. So that's why important that we also just know the formulas. There is again in Excel the combination and the permutation. So there is those two formulas in Excel as well. It is on your calculator, but so please use that, because yeah, I now try to work it out in my head, but then I'm actually missing the formula where you actually divide by the R as well, which I did not. When I said 5 times 4, it should have been the 5 and 4. So I just looked at the permutation and not the combination. So just be careful, because originally I worked out the permutation rule. And it's actually combinations. One thing, at least, there wasn't an answer for me, which normally there is. So I think that is also especially with the permutations and combinations, there is normally always an answer for both. So just be very careful about that. So last 3 or 4 questions. So this now comes back to where we looked at measurements. So let's quickly look at this one. Talbot's biology notebook is 30 centimeters long, 20 centimeters wide. Then they say the dimensions of his desk are in similar proportion as those of his notebook. Okay, so let's rather make this a bit smaller. So let's say that is 50 and that is 20, so that we can still bring in the desk. When I say if a desk is 90 centimeters wide, so if the desk, and let's make that a different color, if that desk is 90 centimeters wide, calculate the area of the top of the desk. Okay, so first we need to work out what is the length of that desk, and then we will work out what is that whole area, including where the notepad is lying. Okay, so first, and this is quite a question again, because first we need to work out the ratio. So 20 to 90 must be the same as 30 to what? So that's the first thing that we need to work out. So the ratio of 90 over 20 is equal to that length, which let's call it x, is over 30. Okay, so how, again, we can work that out. So we've got that. So then let's do a formula on it. So 20 across, so 20 times x. And the other side is 90 times 50, so 90 times 50. So we get that 20x is equal to 2,700. So x is equal to 2,700 divided by 20 is 135. So we know that that length of this desk is 135. So then if we need to work out what the area is length times breadth. But now, first, this is in square meters. So I would first change this into meters. So that is 0,135 meters. That is 0,9 meters. So 0, wait, now again. So let's first, so that is, sorry, 1, 1,35 meters, and that is 0,9 meters. So if we put 90 centimeters is how many meters? It's 0,9 meters. 135 centimeter is 1,35 meters. So 1,35 times 0.9 gives us 1,215 meters square. So let's look at answers. 1,215. Okay, I just want to see how did they get 1,18 is we set that times 2. We would have gotten that 1,62 if okay, wait, did I now do the right calculation? Yes, so that times that. It's interesting. Isn't that the same if you add the two? So if we set 0.9 plus 0.135, that would have given us 2.25. Okay, so there's no, so that one, I don't know how they got to that. 0,27. Also don't have a clue how they got to 0. If you maybe set 0.9 times this, maybe you got to that one. Okay, but the final answer is 1,35 meters times 0,9 because it is for area, it is length times breadth. Okay, but first we needed to work out the ratio. So first we needed to work out what's the length if the ratio is in the same format, and then we needed to work out the area of the top of the desk. Okay, so a bit of a tricky one. It's not just straightforward work out. Then they said, okay, so now you've done it, and then Tabo covers each corner of his desk with a square of cardboard as shown in the diagram below. Calculate the new perimeter of the visual part of the top of his desk. Okay, so now you still need to use that information. So we knew that is 0,9 meters. This was 1,35 meters. But now they go back to centimeters. So let's use what we had in centimeters. So let's quickly check. We had 90 centimeters and 135. So 90 centimeters, 135 centimeters. Okay, and then let's say that is the rest of the desk. So that is also 135 and that is 90 centimeters. Tabo covers each corner of his desk with a square of cardboard as shown below. Calculate the new perimeter of the visual part of the top of his desk. Okay, so is that now what we say is the visual part? So there would be, in all of those, there will be now like, is that what I want? Okay, that is strange. So this is a strange question. So they nearly say work out the perimeter of that. A very strange question. Okay, so this is a interesting question because so we get that length, they now tell us how big that is, but we need to work out the perimeter. So that piece, we can just move in there. The same, that piece we can move in there. So if I move those two pieces, that piece in there, that piece in there, and I do it for all of them, we have the same perimeter as we used to have. So that is how I would have nearly done it. So let's just see if this is one of those that they want to catch us out. So then I will just add the 135 plus 90 plus 135 plus 90. 135 plus 90. So I would have gotten 450, which is option 3. So if I took that as 15 centimeters, because 150 millimeters is 15 centimeters, then it would have been exactly the same, because I would have said there's 60, there's 15, there's 15, so that would add to the 90. I will do it on this side, 15, 15, and 105 in the middle. So that again will give me, no, so this is a very strange one where I would have just kept it as the original, and we need to work out the perimeter. So because we in any case need to work out those pieces, it will come down to 450. Let's just quickly check. So 15 plus 15 is 50. So if I had 50 plus 50 plus 50 plus 50, it would have been 120. So 450 minus 120. See, there's also not one way we now could have get this wrong, that we just want the odd pieces, because that would have given us 350, which is not the option. So this is it feels a very strange question, and I don't know if I wanted to catch us out or not with this one. Yeah, so just again, very, very weird. So I would have done it like this, and then we would have gotten option 3 as the answer. Okay, let's two more questions for tonight. So this, I think, again is a ratio. So a mixture contains two parts of a substance A for every 5 parts of B. So a mixture contains two parts of a substance A for every 5 parts of B. So if the total weight of a mixture is 50, determine how much of substance B is in the mixture. So if there's 50 kgs, how much in the mixture is B? The mixture contains 2 parts of substance. So this is again where my English sometimes fail me. For substance A, for every 5 parts of substance B. So is A equal to basically 5 parts of, or is it the other way around? Substance A for every 5 parts of substance B. So that means there is 6 parts of it, but then 5 divided by 6 times 50 is not going to be one of those answers. A for every 5 parts of B. So if we have 1 kilogram of A, does that mean 1 kilogram of A gives us 5 kilograms of B? Is that how you guys read it as well? What would you guys have said? Because that feels weird. Substance A for every, or am I now reading this wrong? Because if it is this, then I say there's, for every 1 part, there's 5 parts. Okay, so let's say that. So if there is 4, there's 20. Let's see, if there's 8, there's 40. So that also doesn't work out. This is a strange one. Again, my English is now failing me in this. It feels to me the fraction is 1/5 and not 1/6. So that if that is 50 in total, we will have, but see, that is also not, because then that is 1/4. This, I'm going to check this if there's not a mistake in this one, because it feels like 1/5. And then if a total mixture is 50, we can't have, so if that is then around 40, that must be around 10 when we don't. So let me just check this one. I'm not 100% sure if this is correct. How much is the 35.71 divided by 50? That's 0.71. So that's also not. No. Okay. I will check this out because I'm not 100% sure this is correct. And I will get back to you. And then we can start with the profit functions and those things next week, because there's a few that we will go into. I just want to, well, we've got a few more minutes. I just want to quickly check this one out. I am bit weary of this one, and I just want to check my previous reports if I have anything on this so that we can just check what was done. I'm going to stop the recording so long so that I can, so let's just stop the recording while I'm now quickly checking